So, this session is about end to end RAG implementation with evaluation metrics. So, what we'll do is that first we'll explain the RAG concept, we'll go into data ingestion for the RAG, and then we'll explain the query of the RAG, and then we'll go into the RAG triad concepts and then into the evaluation metrics. So, let's jump in and see what is a RAG, which is retrieval augmented generation. First, there is external information, and that stands for the retrieval augmentation. And then there is a generation, which is done by the LLM, which is a large language model. In this example, what we are going to do is that we are going to store the external information in Quadrant, and we are going to store the we are going to have the LLM as the Azure OpenAI. So next what we'll do is that we'll explain the data ingestion. So the data ingestion is composed of various parts. So this is a part. We'll read the file, we'll break the text of the file into chunks, we convert the chunk into embedding. If you do not understand embedding, please watch my other lecture on cosine similarity in embeddings. It should help you in that. Group the chunks into batches and insert the batch of chunks into Quadrant, which is a vector database. Then in the query part, what we'll do is that we'll query by the user. The user will provide the query of the user input. We'll search using Quadrant. The search results, which is included with the metadata, will send to Azure OpenAI, which is the LLM, and the answer sent by Azure OpenAI is sent to the user. So that's the thing. So let's first see this in action. Here, what we have done is that we have already got the quadrant running here, and there will be all these commands will be checked into GitHub. So this is a quadrant which is running here, and we can see that this quadrant is running and it has various collections. And if we see collections here, we should be able to see some of the collections. So here what we have done, we created a collection called Tata Steel, and what we have done is that we have put in one of the Tata Steel corporate brochures of 2021 into it. And you can see the different things that has been uploaded here. How we upload and ingest the data is that's what we are going to show here. So let's see this in action. So first of all, we declared these variables. The collection name is Tata Steel. These are the imports which is there, and we are using sentence transformer for the embeddings. We are using the get PDF data, which is essentially reading the text file. So here we are getting the number of pages, we are using the PDF reader, and we are getting the text here, and we are returning the full text here. So that's how the text is written. And then what we are doing is that breaking the text into chunks, and the chunk length is 500, and we are creating this chunk length. Then what we are doing is that we are creating the model, which is the sentence transformer model, and the model which is we are using is this one, all mini LM L6v2. And once we have done it, we are establishing a connection to the Quadrant client. And then what we are processing is that this is a file path that we are having. So this is a file path that we are having. Now it has only one file, but if it had multiple files, we would be able to read it. So this is how we are processing the file. We are getting the PDF data. We are getting the full text length, and then we are getting the chunks. That means we are chunking it, and then what we are doing is that for each line we are creating the text, we are creating the file name, what is say the PDF, and we are creating the payload, and in this line we are creating the embeddings. So this the full embeddings length. And then after that, if you go back to this slide here, so this is a convert the chunk into embedding, and then we are grouping the chunks into batches. So you see this is a grouping of the chunks into batches, and the chunk size is of 100. So the batch size is of 100, and we are inserting the chunk into quadrant by the upsert method. Please see how we are inserting the vectors here. We are also inserting the payloads also here. And you see here that the full doc text length is around 60,000. The embeddings length is 155. Therefore, we do two batches from 0 to 99 is the first batch, and the second batch is from 100 to 154. So that's the ingestion being done. Now, after we have done the ingestion, what we will do here is that we will do the RAG evaluations, and before the RAG evaluations are done, what we will do is that we will query the database. Okay, so before we query the database, let's jump in and see that what are the RAG evaluations. So this is the actual concept of the RAG evaluation, and I have taken this concept from the TrueLens website. So there are three parts. There is a query, there is a context, and there is a response. So let's see this in action. What is happening here? So once you do the query, what would happen is that we will query the Qudrant database and it would return the search results. So that is the search result that we are getting, which is a context. And this context is sent to Azure OpenAI, and the Azure OpenAI gives a response. So these three things are there. So if you go back, where is the context? The context is search results, and the reply is given by Azure OpenAI, and the query is given by the user. So these are the three triads of the RAG. And so what we'll do is that we'll understand the context relevance between the query and the context, the groundedness between the context and the response, and the answer relevance with the response and the query. Let's see this in action, and we will see how we have done it. So first of all, we have already inserted the data, and this is a user input, which is a query. So let's see while we run it. So let's run it. So these are the imports which are there. And this is a get quadrant client, which is getting the quadrant client. And then what we are doing here, if you see, instead we are loading the model, we are loading the sentence transformer model, as we have said. We are encoding the user input, that is a query to a tensor, which is, and then we are querying the database, that is the vector database, and we are getting the search results. We are limiting it to 3 here, so let's make it 5. And then what we are doing is that we are getting the context here. We are getting the context text vector, and then from the search results, what we will do is that we will print the result. We will also create the full context which we will send to the Azure OpenAI, and we are also appending each of the result vectors and in the context text vectors, and then we are evaluating the context relevance here. What is the context relevance? The context relevance is the similarity between the query and the context. So that is what we are doing here. You see the cosine similarity between the query, this is a query, and this is a result, and that is what we are going to do. So let's see this in action. So this is executing, and since we have given the k is the limit is 5, we are getting 5 results, and for each of them we are getting a similarity score. Okay, so this is got from the database itself. So this is got from the database itself, and also what we are doing is that we are also creating the context relevance by us by doing the cosine similarity. If you see, all of it is the same. So this is how we get the context relevance. That is one of the triads. Now we do a reply. The reply is this part. That is we have got the results now. We are sending it to Azure OpenAI, and it would give the result. So these tests, we are creating the context and we are sending it to Azure OpenAI. So this is the one that we are doing, which is a reply generate answer from context. And once it is done, what we will do is that we will see this in action. So let's see the reply. So this is a reply that we have got. And if you do a pp print, okay, port. So this is the thing, Tata Steel, and what was the question? So the question was, what is the steel production of Tata Steel? And so we get the answer, which is given around 34 million tons per annum. So this gives the reply. So we have got the reply now, and we can see how we are generating the answer from the context. So here what we are doing is that we are creating the prompt with the context and the user input, and we are using the Azure OpenAI to get the answer. So this is a generate answer. If you go to definition, here we are using the chat completions API, and we are using uh, to generate the answer with the help of Azure OpenAI. So you understand that there is a user input, there is a context, and we are using Azure OpenAI model to get it. So this is how we are getting the Azure OpenAI answer. The conversation prompt, we are appending it, and you can see this in code. And the generate answer, we are using the Azure OpenAI chat completion. So once this is done, so we are getting the reply, it's all done. And then what we do is that we want to know the answer relevance metric. So what is the answer relevance metric? The answer relevance metric is the similarity between the query and the response. So what we are doing here is that we are encoding the reply into a reply vector. We are making it into a list, and then we are doing the answer relevance, and it is a cosine similarity, and you are getting this answer relevance here. Next triad, which we have not discussed, is groundedness. So, what is groundedness? Groundedness is the similarity between the context and the response. So, what would happen is that there is five search results here, and for each of the five search results, we'll do the response here. So let's do that thing. So groundedness is a list. So for each context vector in the context text vector, we are doing the cosine similarity. We are having the groundedness, which is because there are five results, we would get five elements in the groundedness list. And the rag triad. The rag triad, what we are doing is that for the groundedness, since we have got five results, we take the mean of it, and for the context relevance, we also had five results, so we will take the mean and let's see what is it happening. So this is how we are getting it. The user input is this, the groundedness is around 0.75, and the context relevance is zero point 0.7, practically 0.697, and the relevance is 0.79. This is a very good grounded and relevant thing that we have got here. Um, so which is quite high, greater than zero point 0.7. So hope through this exercise we have understood the concept of the evaluation metrics, and we have seen it in action from ground up without any use of framework from scratch. Hope you liked it. Thank you. Bye.